The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone, or good morning. Welcome to the second week of our batch. So we have Kalyan, Nilesh, Shrikant, Rakesh. Hi to everyone. Hope you guys had a great week. And today we'll start with our next course of the topics. So let's wait for another 1-2 minutes before people can join in, because I can see that only four people are there. So let's wait for another one or 2 minutes, and then we can start our session. Yeah, good evening, good morning once again for the people who are just joined in. And we can start the session now. I can see the people are still joining in, so let's start the session. Just want to confirm, guys, you can see on the screen that the order is proper. All right, so let's start. Thanks for confirmation, Shrikant and Rakesh. Let me just sign into the AWS Council. So the agenda for today's discussion is we'll start with our Linux EC2. We'll see how to launch our Linux EC2 instance. I guess the launching of a Linux EC2 instance is the same as Windows. The difference is only the the choosing or the choice of the AMIs at the first step. There's no difference at all. But I just want to showcase you that how to know what's the difference, what kind of difference we can see while we can log into our Linux instance as compared to the Windows instance, because we use the concept of something called private key, public private key cryptography, where we have the public key saved on to the AMI, and we have the private key saved on our desktop. So we use the private key to sign on. So till our last week, what we had seen is that we have the Windows instance and we use the private key to generate a secure password. So it generates an auto-generated secure password for initial sign-on, and we can use that password to sign in securely to our Windows EC2 instance. Now, we'll choose a method, or we'll see the method that what's the difference we get while we use the same private key to get a sign-on to our Linux instance. The reason being, when we choose a Linux instance, right, we use a private key to get the root access directly. Okay, we get the root access directly to, so we use a private key to get the root access. So once we cover the Linux EC2, we'll discuss the difference between the public IP and the elastic IP. We'll discuss the concept of ENI, the elastic network interface. We'll discuss the concept of elastic load balancer, and if the time permits, we'll also discuss the auto scaling. So these are the 5 topics that I am intending to cover today itself. Load balancer and auto scaling are lengthier topics. So even if we can cover till elastic load balancer, if you're not able to cover the auto scaling, we can do it tomorrow. So today's agenda is we cover the Linux EC2 part, public IP versus elastic IP, elastic network interface, and elastic load balancer. So at least we should be able to cover these 4 topics. All right. So let's get started. To start with, I'll launch a Linux instance in front of you real quick. Now I have discussed the options in the previous week, so I'll not discuss the options again. But I'll just go to the point where I'll show you how we use a private key to get a secure access, the root access to our Linux instance. So right now, okay, let me just sign out, because I have 2 or 3 different accounts for the AWS, so I need to ensure that I am logging into the right account. Hang on one second, please. Okay, this is the right one. All right, so I go to the EC2 on the left side on the compute section. Now, right now, we'll just click on Launch Instance. So I will be launching the instance in the North California region. This is my preferred region. Now, there are so many Linux distributions for me to choose. I can choose Amazon Linux AMI, Red Hat Enterprise Linux, SUSE Linux, Ubuntu Server. So there are different type of Linux distributions that I can go for. Even I guess we have CentOS as well. So let's go ahead and let's choose the Amazon Linux AMI. And the rest of the options are the same. We'll go with the t2.micro as our instance type, which comes under the free tier eligible category. And once we go over here, we'll choose any one of the subnets associated to one of the AZs in this region. And I'll keep all the options as it is and click on Add Storage. So we'll keep the storage options as it is. By default, with the Linux instance, you get the 8 GB of root volume. Right. So I'll not increase or decrease its size. I'll keep it to default and click on Tag Instance. So I can just type in any value. For example, I can just type in, let's suppose, Linux instance. I'm sorry. And we click on Configure Security Group. So we have already discussed these steps before. To refresh that, our security group is a set of firewall rules that we assign to our instances, and we are able to define what kind of traffic can reach or leave our instance. So I'll create a new security group, so I'll name it as Linux EC2 S3, and I'll just copy and paste the same in the description as of now. Now I want the SSH. By default, if you want to get a root access to a Linux instance, you will use the SSH as a protocol that stands for Secure Shell that communicates over port 22. It is up to you what is the source you want to choose. I choose my IP for the security reasons. And optionally, if this was a web application, or if you're planning to launch a web application, then you can add multiple rules for the HTTP and HTTPS. As of now, I'll just keep it too simple. I click on Review and Launch. I can review all the options, launch the instance. Now, I'll just choose a new keep here, or let me do one thing. Let me proceed. I'll just choose an existing keep here that we used for the Windows instance in our previous week. So I'll go with the Linux EC2 KP, right? This private key is already saved on my desktop. And so I acknowledge that I have access to the selected private key, and I click on Launch Instance. So my instance is being launched, and it will take a while. So I'll show you both the procedures. Procedure to get access, the root access to the Linux instance using the Mac terminal, and also we'll use PuTTY on our Windows machine to see that how we can get the root access to our Linux instances. So in the meantime, this Linux instance is being getting launched. Let's go ahead and I will open my Windows 10 machine. All right, so we are logged into the Windows 10. Okay. All right, so let's wait for a while for this Linux instance to log in to be up and running. Because once it is up and running, over here it is saying status check as initializing. We should get 2x2 checks. So once we get 2x2 checks, it means we are good to go. We can go ahead and start logging or get the root access to a Linux instance. We'll try the Mac terminal first, and after that we'll just go ahead and we'll just go with the Windows one. We'll use the PuTTY as our standby client. Okay. So let's wait for another few seconds. I guess we have a question right now. Rakesh is saying how we get the Windows VM on the MacBook. Is it tool for the VMware? Yes, Rakesh. There's a tool called VMware Fusion. This one. On the left side where my cursor is. It's a freeware for first 30 or 60 days. Then you have to buy the license. So I already purchased the license from them. I guess it costs around $300 to $400. So upon this VMware Fusion, I have launched my ESXi, Windows 10, so I launched multiple machines on my MacBook. Because sometimes I've seen that on the Mac OS X, there are some kind of restrictions, some software that they don't run properly. So Windows is the best solution. But Shrikant is saying Parallels can be also used. Of course, Shrikant, Parallels is also a very good software as compared to VMware Fusion, but I've used the Parallel for quite a while. I used for the trial for one or 2 months, but I've seen that while I use the Parallel, it heats up my MacBook. I'm not sure what might be. It consumes a lot of RAM or something like that, so that's why I have to remove the Parallel and go with the VMware Fusion. Otherwise, Parallel is also a very good option. Okay, here Shrikant is saying it's true in my case as well. In that case, you can just try the VMware Fusion. Believe me, it is one of the excellent softwares available in the market. I run so many virtual machines, it never heats up a laptop. I'm running the ESXi, Windows 10, and so many things. It never heats up a laptop because the MacBook you already have. We have seen that there's a heating issue. So I don't want to worsen it using some kind of softwares. Okay, so I guess our Linux instance is being up and running. Now, let me just open my terminal. Now, this key that I have used to get access to the instance is already saved in my document. So if it is to perform the LSLA, I have the Linux instance, this one, Linux ec2-kb.pem saved in my documents folder. Now, if you are using it for the first time, now this key I've already used that, then you have to change its permission. So you have to run the command chmod 400. So you have to go to the document or the place where your instance is, I'm sorry, the key is being saved, chmod 400, and then you have to just type in the name of your key so that you can define the right permissions for the for your key, right? So I've already defined the permissions before that because I've been using this key for quite a while now. So I will just use this key and just log into my instance directly, right? So I'll run the command ssh-i, then I'll just type in the name of my key file, Linux ec2-kp.pem. Now, by default, if I'm using the Amazon Linux AMI, my user ID should be ec2-user. How you can get to know? If you click on connect, let's suppose if you hit on connect, you just go to Java SSH client over here. So this is your username, right? So I'll just connect and just type in ec2-user @ and I'll just copy and paste the public IP of my Linux instance. You'll use a public IP, not the private IP, because you're connecting to this instance via the internet. So you have to use a public IP, right? So ssh-i, Linux ec2-kp.pem, ec2-user, that's the user ID of my Linux AMI instance, and the IP address of it. So I hit enter now. And it says, are you sure you want to continue connecting? You say yes. And we are connected. So for the Mac, it's quite simple. Nothing that much. You don't need any third-party client. You may have, but you can very well use the terminal to connect securely to your Linux instance. It is just that you have to define the permissions for the key. Run the command chmod 400. So you have to go to the directory where your key file has been saved. Once you change to the directory, run the command chmod 400 and type the key name, the full format, and once you define the permissions, you're good to go, right? So nothing much about from the Mac terminal perspective. The other way, I don't think it's very efficient, is to use the Java SSH client. So if you hit on client, you can use this called Java SSH client, which means that if it will use the Java within your browser, it will open a window so that you can connect to it. So you can type in the path over here where your private key is being saved on a local PC, and you can connect to it. But I've seen most of the times it doesn't work, and some of the browsers they don't support that. I guess Chrome has already blocked the Java because they've outdated the Java, so they're not using the Java too much. So they've blocked the Java access. So this is not that much efficient. So I guess you should use a standalone SSH client like Terminal or PuTTY, depending upon which operating system you're using. Rakesh, permissions within the file means that, for example, let me just hang on one second. Let's suppose that I have my key file saved in my documents folder. So I just go to CD documents. I perform the ls/la to see the list of the key files that are saved over there. For example, I have this key example2-kp.pem. Now, if I've downloaded this key file for the first time, I have to define the permissions first. So I have to run the command chmod 400 example 2-kp.pem. So once I've defined the permissions correctly, then I can go ahead and run the command to log into my instance. That's it. All right. Okay. Now, we'll see from the Windows perspective. So the second one is you can use the Java SSH client, but it's not a very effective method, believe me. I use that sometimes, but sometimes it freezes, sometimes the browser doesn't support it. So I've relied mainly upon the standalone clients or the terminals. Now we'll see from the Windows perspective. Now from the Windows perspective, you need two softwares, PuttyGen and Putty. So if you just go to the Google, you can just download them for free. They are freewares that you can just download. Okay, I'm sorry. So we use Putty. Download. So there's so many. I think this one is the right one. Yeah. So you can just now go to the site and this one, and you can just download. So if you just go to Google and just type in Putty space download, you can either go to putty.org. Normally I download from this one, the second site. And you have to download two softwares, putty.exe, this one, and the other one is called PuttyGen. PuttyGen is used to convert your .pem file, the .pem file to .ppk, because .pem format files are not being supported by Putty. You will use Putty to sign in securely, like we use the terminal in the Mac, but you use the PuttyGen to convert the format of the key, the extension of the key, right? So what I will do is I'll open the PuttyGen first and show you the procedure to convert the .pem file. Hang on one second. Let me just go to downloads. Okay. So I have this puttygen.exe. So I've opened this. So once you download the Putty generator, you will open this window. Now you need to convert the .pem file. Now this one, for example, let's suppose this one, Linux ec2-kp.pem, and this is the one that I have used to sign into my Linux instance. This one is in the .pem format. If you see on the top, it is in the .pem format. I need to convert that into .ppk format so that the Putty can accept it and help me to sign in securely to my Linux instance. So once I open the Putty key generator, I need to upload the file. So on the left side, go to File. Once you go over there, click on Load Private Key. And once you click on Load Private Key, just go to the location where you have the .pem file saved. So I have many, so I'll just convert that into the all files. And okay, this is the .pem file that I need to convert. I select this one, and this uploads the entire content of the .pem file. Now, in order to convert that, I click on Save Private Key. Over here, Save Private Key. It says, are you sure we want to save this key without a paraphrase? Yes, we can. And now it will give me the option to save this file in the .ppk format. So I'll just name it as Linux test-kp.pem and hit save. I'm sorry, it will be .ppk, right? So it will be Linux test-kp, and I want to save that in the .ppk format. So the save as type would be automatically .ppk. I hit save, and this saves. Now this one, if you can see my cursor, this is my .ppk format file, right? I guess till this point it is clear. You will use the putty key generator to convert the .pem file to .ppk. I'll show you the step again. You open the .ppk. So I have saved that exe file on my downloads file. So you open the putty key generator. You go to files, load the private key, search for the .pem file that you want to convert to .ppk. For example, I'll choose this one. And once you import this key, hit OK, and then go to save private key. Skip the step by hitting yes, and I'll save this key in the .ppk format to any one of your preferred locations. So I'm just going to test to it's a test 4. That's it, and it will save that in the .ppk format. So this .ppk format will be accepted by the putty client software, right? I guess until this point it is quite clear. Srinivas has a question. Can you show how to generate a .pem file? Srinivas, whenever we download the file, it is already in the .pem format. Whenever we download the file, it is already in the .pem format. So we don't need to convert that. So in the original instance, in the original Go, so whenever you launch the instance, it automatically generates in the .pem file. Okay. So now, once we have converted the .pem file to .ppk, it's time for us to use the putty to sign in securely. So I'll use I open the Google Chrome on my Windows PC as well. The reason being because I'm not able to sometimes copy and paste to and fro, back and forth from the Mac to the Windows. So let me just open the AWS Management Console. Just hang on one second. Okay, so all right, so let me just open the EC2 so that I can pull out the information like the public IP of the instance. Therefore, I open the instance right now, and now I'll just open the putty.exe. Right. First thing first, I need to define. I go to sessions over here. I open the putty. I go to sessions. First thing first, I need to copy and paste the public IP of my Linux instance. So I just copy this one, 54.153.63.193. So I'm just copy this one, and I just paste it. I'll keep the port 22 and the connection type as SSH because we're using the SSH over port 22 to connect to this Linux EC2 instance. Right. Once we define the basic options, once we define the host name, port, protocol, and everything, it's time for us to upload the .ppk file that we have saved on our desktop. On the left side, where you can see my cursor, over here, you have a SSH. So click on plus sign to expand it. And under SSH, you have AUTH. Highlight this one. And now you have to browse for the key file that is saved on your desktop. So I just browse my .ppk file that I just created, right? And once I browse for it, I go ahead and click on open. So I get this PuTTY security alert. I hit yes, and I just type in login as. Now since this is an Amazon AMI Linux instance, the default user ID would be EC2-user, and I'm authenticated. Plain and simple. So that's how you will use the PuTTY to get a secure root access to your Linux instance. Now, I have shown you both the ways, Mac terminal and the PuTTY, but my main intention to show you is that you use the private key to get the root access to your Linux instance. Opposite to this, if you use a Windows instance, you get a, I would say, an auto-generated password for initial sign-on. Right? So that's the difference using the private key to get the secure access to both your Windows and the Linux instances. So that's the difference I wanted to show. Okay. Any questions? Any doubts so far? So this completes our launching and connecting to our Linux instance. And I guess the difference between using the private key to connect to the Windows instance and the Linux instance, it's quite clear. Any questions, any doubts before we can just wind up this topic and we can switch over to the public IP and the elastic IP difference? I guess we have a question right now. Shrikant is saying, if I need to go to the root account, is it possible? Shrikant, this is this user ID that you log in, EC2-user, you have the root access. It's a root account only. Right. So you have to do all the possible changes that you do on the Linux to define the users and permissions. But this is this user ID, EC2-user, has all the root access. Okay. So that's it. Now we will do. Let me do one thing. Let me just launch another Linux instance real quick so that we can just perform this the lab session for the elastic IP and the public IPs. Hang on one second. I'm just launching another instance in another easy real quick. I'll just name it as Linux instance 2. Okay. Confidence security crew. We will launch. Choose a keep here and stop. Okay. So we can start our topic now. So our next topic is the difference between the elastic IP and the public IP. Now this is a difference that is this is the topic that is quite important for us to cover, and this is the topic that confuses many people. The reason being, people tend to get confused between the public IP and the elastic IP, and most of us we assume that public IP and the elastic IP is the same. Yes, they are same, but the nature and the way they work is completely different. It is quite important for us to know the difference between the two, how they work, what are the advantages we get out of the elastic IP as compared to the public IP, what are the limitations, what are the restrictions involved, what's the cost involved. Right. So let's go ahead and start working on the concept that's quite important: public IP versus elastic IP. Right. before we can just jump over to the theoretical thing, right? Let me just now filter my first Linux instance that we launched for our first topic, this Linux instance. Right now, if you see this Linux instance, it has a private DNS, a private IP, which will never change, because the private IPs they get it from the subnet range. They're static in nature, and they will stay over there. Right to this, you will have a public DNS and a public IP. Right. Now the public IP is quite critical for us, or crucial for us, I would say that, because if we want to get access to our instance across the internet, we'll use a public IP. Right now, right now we have connected to a Linux instance, this connection was established over the internet. The reason being, right now this Linux instance is being running in one of the hardware in the AWS data center in the Northern California region. So I used the internet as a medium to connect to this Linux server, or the Linux virtual machine. Right? I guess you agree with me. So in that case, public IP is quite important for me. So I'll just copy and paste this public IP. And so this is my public IP of this Linux instance. I'll just name it as public IP to make it more clear. Right. So the public IP is 54.153.63.193. Let me just open the WordPad file to make it more broader in terms of view. Okay, so this is our public IP. Now, let's do one thing. Let's go ahead and stop this instance, and let's see what happens. Okay, so this instance is getting stopped. We'll wait for a few seconds for this instance to show us some kind of changes. So this instance is in the process of getting stopped. We refresh this page. Refresh it. It's still shutting down. Let's wait. Okay, so this instance is fully stopped now. It is completely stopped, and you notice one thing: the public IP is gone. It's no more there. Which means that whenever we stop the instance, the public IP would be gone. Let's do one thing. Let's go ahead and start this instance again, and let's see what kind of thing we get. Whether we get the same public IP back. So let us start this instance again, and let's see what it does. And as soon as I start this instance, I got a public IP 54.183.65.70, right? Which is different from the one that I had at the initial stage. Previously, I have the public IP of 54.153.63.193. Now this is the public IP I have 54.183.65.70. But it's quite different from the above one. So now, which means that if I restart my instance, if I shut down and start the instance again, my public IP would be renewed. I'll get a new public IP. Now, from our perspective, as of now, if we keep the thing simple, it will not affect us. But from the end user perspective, if we are running a web application on this Linux instance, it makes a hell lot of difference. How? For example, let's suppose let's take an example of this user. So this is a user, and he's sending the traffic to your instance. Right? On this instance, you have your web application, your website running. Now, it is quite obvious that for this website, you will have a DNS name, a domain name mentioned. For example, it's xyz.com. So, user will type in xyz.com, and he will be able to access the web application or the web pages on his server. Now, this xyz.com, let's suppose it is being binded to your IP address 54.153.63.193. Now, binding of the DNS is a manual procedure, right? You will use a Route 53, we'll discuss later on, to convert your domain names into the public IPs of your instances, right? So the user is typing xyz.com, it is getting converted to the public IP which belongs to your instance. Till this point, everything is smooth. Now, what happens if the instance restarts? Once the instance restarts, it will get this new public IP. Now, the user will type in xyz.com as he used to do before. He will type in xyz.com, his domain name, but this domain name will still resolve to the old public IP which is not a part of this instance anymore. Which means the user would not be able to reach your website or the web application because this xyz.com in actuality is now being binded to this new instance. But your DNS entry is still old and xyz.com is taking or resolving to the old public IP. Right? So having a public IP is a kind of a disadvantage because if your instance restarts, might be you are restarting intentionally due to some maintenance purpose, might be it is in frozen state, sometimes the instance might restart automatically. If it doesn't happen, then you will never know, and the website or the user will not be able to resolve, or at the back end the DNS entries will not be able to resolve to the correct IP, and the user will not be able to reach your web application. I think it makes quite sense now. So a public IP is subjected to change. I repeat, I quote, a public IP is subjected to change if you restart the instance. Right? Let's do this exercise one more time. I'll just go ahead and so this is my second time, or I would say this is my new public IP that I got it. Right. Now, if I just restart the instance again, still it will just now give me another public IP. So what happens at the back end is that Amazon Web Services, they maintain a pool of public IPs. Once you stop the instance, the public IP gets back to the pool, and once you start the instance again, the Amazon Web Services give you a new public IP from its pool. Why? Because this public IP, this one, is always intact to your instance. It is never intact to account. So once the instance stopped, once the instance stops, there is no relevance of the public IP. Therefore, once the instance gets stopped, the public IP is bounded to release because it is saying that I don't have any purpose now. Let me release myself and get back to the AWS pool. So you can see the instance is stopped, the public IP is gone. Now if I just go ahead and start the instance again, I will see a new public IP. So let's see what's the public IP we're getting. Now we have got a new public IP. So every time you restart the instance, you will get a new public IP. Now this time we have some different public IP, 54.183.118.170, which means that every time if you have to restart the instance, you have to change the DNS entries at the back end, or if the instance restarts automatically, you have to keep a check and manually change the DNS entries. Otherwise, your website will not be reachable because your DNS settings will resolve to the old public IP without even knowing that a new public IP has been associated to your instance now. Right? Now, as a solution, we have a thing called elastic IPs. And then at the left side, under the EC2 dashboard, where you have the security groups, where you can see my cursor, you have the elastic IPs. Now, elastic IPs are same as the public IPs. There is no difference at all. I repeat, elastic IPs are same as the public IPs. There's no difference. Both help your instance to be reachable across the internet. Both make your instance publicly accessible. But the elastic IP intact, or it remains intact to your account. It never changes even if you restart your instance. Let me show you how. I go to elastic IPs. Right now, I don't have any elastic IPs allocated to my account. So now elastic IPs are region specific. If you see this message on the top, you don't have any elastic IPs for this region. So you have to keep this thing in mind, that the elastic IPs are restricted to be used within the region. You can't use the elastic IP of the Northern California for the instance in the North Virginia. It can never happen. So I just go ahead and allocate a new address. It says, are you sure you want to allocate a new IP address? Yes, we are quite sure. We'll click on yes, allocate. Now, as we allocate this instance elastic IP, this is of no use as of now, because you can see this instance field is blank. Even though we have the elastic IPs allocated, it is not assigned to any of the instance. So how to assign it? We just go ahead, go to actions and click on associate address and choose the instance. So I go to instance, it will show me the list of instances running in the same region of Northern California. Now I go to Linux instance right now and hit, and at the top right corner, bottom right corner, I'm sorry about that, you have this cancel and associate. I click on associate. So this elastic IP is being associated to my Linux instance. As soon as I do that, the previous public IP has been released and the new elastic IP is equal to the public IP. If I just go back, let's do one thing. This is the elastic IP. If I just go back, this previous public IP has been released now, and now I have this new elastic IP. This previous public IP has been released, and now I have this new elastic IP, which means as soon as I assign the elastic IP to any of the instance, the previous public IP would be subjected to be released, because now I need a room to assign a new elastic IP to it, and that new elastic IP would be equivalent to my public IP. So it is 52.8.60.12. What I will do is I'll just go ahead, go to actions and stop this instance and see what happens. So this instance is stopping right now, and let's see if it releases its elastic IP which is equal to the public IP. So I guess till this point of time the things are quite positive. Still we have the elastic IP intact. So you can see this instance is completely stopped, and my elastic IP which is equal to the public IP remains over there. It never releases itself. I go to actions, start this instance again, and you will see that the elastic IP or the public IP will stay at its own place. Why? Because the elastic IP is intact to my account. It is associated to my account, whereas the public IP is associated to the instance. So even if you stop instance again, even if I terminate or delete this instance, the elastic IP will stay over there. Right? So this is the first major advantage and the difference between the elastic IP and the public IP. Public IP is subjected to change whenever you restart the instance, whereas the elastic IP never changes even if you restart the instance multiple times. That's the first major difference that you have to understand. Second thing, let's take a scenario to make it more understandable what I'm trying to say over here. Let's suppose that if this is a user and he's sending the traffic to one of the instances in your 1A availability zone, right? Now, due to some reasons, now with this 1A, this instance, you have an elastic IP assigned. Now, this instance over here, this one, is your primary instance, which means that, okay, you are running it as a primary server, and this should be in healthy state. Opposite to it, you have another instance running in 1B, AZ in the same region, and this is your backup server, which means that it's your backup on the standby server. You will never use that unless there's some kind of some issue, or you want to divert the traffic to it, because the backup server, this is a standby server. You will use that in the case of urgency. Now what happens is that let's suppose that you have to take down this instance. Might be due to some security reasons, some maintenance purpose, some patching, or might be this instance has been corrupted. Something went wrong with this instance intentionally, or might be you are doing some kind of maintenance work. What you can do is you can take the elastic IP of this instance and interact it to another instance in the same AZ. This instance would have the same kind of web application running. What will happen in this case? Now the user's traffic will be rerouted to another backup of the standby server in a separate AZ. It can be the same AZ, but in this example we have a separate AZ because the only condition is that the elastic IP, it works within the region. Elastic IPs help you to perform the failover as a workaround. You have some automatic procedures in place that we'll discuss later on, but the elastic IPs will help you to perform the failover. It's kind of a workaround, right? Now this kind of capability, this kind of association and disassociation, you cannot achieve using the public IPs. Quite and simple. Using the concept of public IPs, you cannot achieve this kind of capability. So I'll show you how we can achieve that. So for example, let's do one thing. I want to play around with my Linux instance, this one, and Linux instance 2. On the top that I have the Linux instance, I have the elastic IP assigned. What I need to do is I need to disassociate this public IP, this elastic IP 52.8.60.12 and assign it to my Linux instance 2. Right. Now, as my first step, I'll go ahead and disassociate this elastic IP with my Linux instance. Now you will notice one thing. As soon as I do that, it will get a new public IP. Okay, so let's do that. I go to elastic IPs. I need to disassociate this elastic IP from this instance now. So I'll just go ahead, go to actions, and click on disassociate address. It says, are you sure you want to disassociate this elastic IP? Yes, of course we are sure. And we click on yes, disassociate. This has been disassociated now because you can see this instance box is blank. This instance field is blank. Now we go ahead and check our instance. This Linux instance we have taken out this elastic IP from this Linux instance, and now it has got a new public IP. As soon as I disassociate the elastic IP from this instance, the AWS at the backend will automatically assign a new public IP from its pool that it maintains. Right? So now this elastic IP, which is sitting idle, which is doing nothing, I'll just go ahead and assign it to our Linux instance too. Now, as soon as I do that, this previous public IP will be released, and this elastic IP will take over. So I'll go to Actions, associate to my Linux instance 2, and we're done. So this Linux instance 2 has a new elastic IP now, and the previous public IP has been released back to the pool. So this is how I can play around with elastic IPs. This kind of capability, this kind of association and the disassociation cannot be done using the public IPs, because the public IPs are not under our control, but the elastic IPs are. Right? So you have seen two major differences between the public IPs and the elastic IPs. Public IPs are subjected to change whenever you restart the instance, whereas the elastic IPs don't. Using the elastic IPs, you can perform the manual failover procedures in case of any kind of unexpected instance fails. So this kind of association and disassociation of the elastic of the IPs, you can achieve that using this concept of elastic IPs. You can divert the traffic temporarily, but this kind of temporary association and the disassociation cannot be achieved using the concept of public IPs, because the public IPs are not being controlled by us. It is being controlled by the Amazon Web Services at the back end. So the kind of advantages and the kind of flexibility that we get with the elastic IPs, we never get that with the public IPs. Right? So that's the difference. Any questions, any doubts so far? Please let me know. See, the thing is, if someone asks you public IP, elastic IPs, yes, they are same. Both are same. The purpose of the elastic IP and the public IP is to make your instance publicly reachable or reachable across the internet. But the nature, the way they work is completely different. Okay. Now, I'm just waiting for your questions. Please let me know if you have any questions before I can just go ahead and start discuss some more concepts on this topic. Just give me a second over here. Guys, in the meantime, you can just type the questions. I'll be right back. Just give me a few seconds over here. I guess we have a question right now. Sorry about that. I'm just back now. Sure, is saying, can you show me one more time the list machine login? I've lost my internet connection. Sure. Unfortunately, we already crossed that topic. I would really appreciate it if you can see the recording, because if I just go back to the topic again, we will lose our track for this topic. So please check the recording later on. Okay, it's quite simple. Just in case if you have any trouble, you can let me know later on. Okay. First, so that's about the difference. So let's go ahead and start with our theory. I would say we have already done that, but we'll just go through the slides to revise these concepts that I've shown you in the practical scenario. Nilesh, I'll come to the price. Public IP address. Public IP address is reachable from the internet. From the pool of IP addresses, this is assigned to instance, and it is not associated to your AWS account. So we have to understand this fact is that the public IP is never intacted to account. It is intacted to your instance. Through NAT, or the network address translation, the public IP is mapped to the private IP address. You use the public IP for communication between instances and for internet communication. Every instance that gets a public IP also gets an external DNS host name. So you have seen that. So you get this DNS host name whenever you launch your instance or when you get the public IP. Public IP cannot be manually associated or disassociated from your instance because it is not under our control. Public IPs are completely managed by the Amazon Web Services. Therefore, if we can't perform the failover procedure like we can do with elastic IPs. So the public IPs cannot be manually associated or disassociated from your instance. Okay. After the release of public IP, you cannot reuse your public IP once it is disassociated from the instance. We have seen that. Once you restart the instance, the public IP is gone. You can never get it back. So every time you restart the instance, you'll get a new public IP. The public IP gets back to the address pool. When you restart an instance, it gets a new public IP. We have seen that. Right? So that's about the nature of the public IP. Regarding the elastic IP addresses, your elastic IP address is a public IP that you may allocate to your account. So elastic IP is the same as a public IP, but elastic IPs are never being assigned to your instance. It is being assigned to the account. So we assign it to the account, and then we allocate to the account, and then we associate to the instance. So in a nutshell, elastic IP addresses are being allocated to the account directly, not to the instances. An elastic IP allocated to your account unless you release it. So you can also release your elastic IP. So if I just go back, let's suppose if I just want to go to elastic IPs, I can also release this elastic IP. So I need to, for example, I can go to actions, disassociate from my instance, and then I can go to actions and release it from here. So it will be gone. It may take several minutes to remap an EIP. It is not required to have an EIP in all your instances. See, there are some restrictions that are there with Elastic IP. I'll let you know. But it is not mandatory that you will use Elastic IP for all your instances, because the public IP will also solve the purpose. Now you are limited with 5 elastic IPs per region. Now this is the restrictions that you have to keep in mind. You only get 5 elastic IPs per region. That's the only limit you have. Above that, you don't get more elastic IPs. Yes, you can get, but there's a negligible cost involved. You have to open a case with Amazon Web Services, and they may look over your case and may assign you more elastic IPs per region depending upon what your need is. With the public IPs, there is no restriction, but with elastic IPs, you get only 5 elastic IPs per region, and these are free. Now regarding the pricing model is quite weird. So you get 5 elastic IPs per region, per account. This is a restriction, and also this is the limitation, and this is these are free. these 5 elastic IPs that you get per region as a restriction or as the condition that will only give you the 5 elastic IPs, these are absolutely free. But there's a big star, terms and conditions applied. Even these are free, you can be charged for these 5 elastic IPs. How? If you keep your elastic IP idle and don't assign it to a running instance, I quote, you can write it down. If you don't assign an elastic IP to a running instance, then you'll be charged, even for a free elastic IP. Right now, you can see this instance is not assigned, this elastic IP is not assigned to an instance. It is blank. This elastic IP is not assigned to an instance, which means even though this elastic IP is free for me, but Amazon Web Services will charge for on the hourly basis because I haven't assigned it to any of the instance. So an elastic IP, if it's sitting idle and not assigned to an instance, you will be charged for that. Second condition is that even if you assign to the instance should be in running state. So I go to actions over here, associate to any one of the instances. The condition is that any of the instances that I'm assigning the elastic IP should be in running state. If I'm talking about running state, I'm talking about this one. If the instance is stopped, let's suppose I go ahead and stop this instance. Once I stop this instance and I keep the elastic IP intact to it, even then the Amazon Web Services will bill me for this unused elastic IP. So that you get 5 elastic IPs per region per account as a restriction and as a free tier category you get for free. But if you don't assign the elastic IP to any running instance or it is sitting idle, in that case you'll be charged for that. Now you might be asking the question, why this kind of weird model? The reason being, they want to discourage the wastage of the public IPs. Now the guys who are from the networking field, you might be aware that there's already a shortage of the IPv4 addresses. Just give me 1 second. I'm sorry about that. So there's already a scarcity of the public IPs across the world in the networking domain. So to discourage the wastage of the IPv4 addresses, they're saying that we'll not charge you. If you use that, we don't charge you, but if you waste that, we'll charge you. So just in case if your elastic IP is sitting idle doing nothing, it is better that you disassociate and release it. So go to actions and release your elastic IP, so that you are not being charged if you're not using the elastic IPs to the maximum potential. So the elastic IP should be assigned to a running instance, and it should not be sitting idle. If it is, then you'll be charged even for a free elastic IP. So that's the billing model. You get 5 elastic IPs per region per account for free. This is the only quota you get. And if you want more elastic IPs, then Amazon Web Services may think to give more elastic IPs for some amount of cost. So that's it. That's the difference between the elastic IPs and the public IPs. Any questions, any doubts before we can just take a short break? So I guess I made myself very much clear regarding the difference between the two. Just in case if you have any doubts further, please feel free to let me know. Because there should be not even a single doubt in your head that what's the difference between the two. Because it's quite important for us to know from the examination perspective and also from the interview perspective, because this is a very common question that is being asked. And most of the times people confuse between the two, even though it's quite simple. But normally we think that elastic IP is both is same as a public IP. There's no difference. Both are same, but yes, there is a hell lot of difference if you see the how they work at the back end. All right. Any questions? Any doubts? Because I think we should take a 15-minute break. You can have your dinner, or you can refresh yourself, and then we can start with our next topic. That is the elastic network interfaces. Right. To summarize, elastic IPs are static in nature. You can perform the failover using it, and you get 5 elastic IPs per region per account as a restriction. And if you don't use the elastic IPs judiciously and wisely, then you'll be charged for that. Any questions, any doubts? So I guess, Nilesh, this answers your question, right? I think no questions as of now. So let's take a 15-minute break. Please be back by 9:57 or by most probably by 10 o'clock. Okay, so yeah, so 9:57. Please be back by that point of time, and then we can continue with our conversation. So you can refresh yourself, and once we come back from the break, we'll start with our elastic network interfaces. So it's a break for 15 minutes, 1-5. All right. Thank you. Yeah, welcome back. I guess all the people are back now. All right, so let's start with our next topic, that is called the ENI, or the Elastic Network Interface. All right. Elastic Network Interfaces. Now, what exactly is an Elastic Network Interface? See, if you just go back to the instances, see, like we have in our laptops, we have the NIC cards, network interface cards, or the LAN cards. Those LAN cards or the network interface cards help our machines to get IP addresses, and we have the MAC addresses binded to our LAN cards. These LAN cards or the network interface cards help our machines to be a part of any other network or to communicate on different networks. For our instances, we have the virtual network interfaces in the form of ETH0. That's the primary or the default network interface. Right? If you just go to ETH0, and it will just populate some of the details of it. For example, the interface ID, VPC ID, attachment owner. That's my account ID of my AWS account. I would say that. Attachment status. It is attached. The date and time, and private IP address, private DNS name, elastic IP address, and all those kind of things. If I click on ETH0 and I just go to interface ID, it will take me to something called network interface dashboard, which you can locate under network and security, where we have the elastic IPs, placement groups, secure key pairs, network interfaces. So this is my default network interface that is being associated to my Linux instance. Right. Now, if I just go to actions, I can just go to manage private IP addresses. So this is the private IP and the associated public IP that is being assigned to the network interfaces, to the network interface, and the same gets replicated to the instance to which this network interface is assigned. What happens is, at the back end, if you're assigning the IP addresses, we are in actuality assigning these IPs to the network interfaces that are binded to our instance. If I just go back to the instance to which this network interface is being assigned, you will see the same IP address will show up, private IP and the public IP, this one. Right, so let's go ahead and start discussing our network interfaces. Now, the network interfaces can help us to achieve multiple purposes. It can help us to assign multiple IP addresses to a single instance. It can help us to perform the failover. It can also help us to perform some kind of administration network. So we'll discuss all the functionalities, all the insights of it. So, a virtual network interface is attached to an instance. So whenever you launch an instance, a default network interface is being attached to it. Now we can also assign multiple network interfaces. That's a different story altogether. Well, we can also assign multiple network interfaces. But by default, whenever you launch an instance, a default network interface called ETH0 is being assigned to it. Each instance in a VPC or a virtual private cloud has a default network interface that you denote or represent by ETH0. Now, this default network interface, not default, I would say that. Let me correct myself. You have the ability to attach or detach this network interface from the instance at any point of time. It's the same capability that we get with the elastic IPs. You can attach or detach your network interfaces from the instances at any point of time to accomplish the failover procedures. An ENI that you detach from an EC2 instance can be attached to another one. It's the same thing that we have seen in the elastic IPs. We can perform this association and disassociation, but the only difference over here is that we can play with the elastic IPs within the region. However, if we talk about the network interfaces, we can only play around within an AZ or the availability zone. So the failover scope is lesser as compared to the elastic IPs, because with the elastic IPs we can perform the failover within the entire region, but the network interfaces is restricted within a single AZ. So the scope is very much less. Now an ENI will consist of a private IP address. We have seen that additional private IP addresses we can assign to it, public IP address associated with each private IP address, MAC address, security groups, source and the destination check flag, and the description. Let's do one thing. Let's go ahead and just check our elastic IP. I go to, let's suppose, I go to the top one Linux instance, and I just go to the network interface, the default one. Just click on its interface ID. This will take me to this interface dashboard. Now over here, if you just see the details of this default network interface, this thing, MAC address. This is a virtual MAC address that is binded and it is unique in nature. If I'm saying unique in nature, which means that every network interface that you pick will have its own MAC address, and it will never overlap with any other network interfaces. So the MAC address is the same thing. We also have the MAC addresses embedded on our network interface cards in our PCs, in our laptops, right? So MAC address is unique in nature. It is being binded to each of the network interface, that whether it's a default one or the one that you create by yourself. Once you check the MAC address, you can also have there's a security group. You can also assign the security groups to the network interfaces. Now this security group, it is picked from the instance. While we launch this instance, so we assign the security group. This is the private DNS name, and the primary private IP, the public IP. Right. So these are the details that we can check out once we open the details of a particular network interface. Now, here comes the main thing. Let's suppose that today you want to assign multiple IPs to a single instance. How are you going to go about doing that? Because there are times that you may need to assign multiple IPs to a single EC2 instance. Yes, you can come across this kind of situation. For example, let's discuss an example to make it more understandable what I'm trying to say. This is your user. I'm sorry about that. So this is your user, and he's sending the traffic to your instance. For this instance, you have this xyz.com domain associated. Quite common, because you will never ask the user to send the traffic or just have the public IP of your instance. You will just give him a nice looking domain name to browse. Now, this domain name can be assigned to either a public IP or an elastic IP, depending upon whatever you have chosen. Right. Now, there can be times that a public IP or an elastic IP can be not reachable. It can be unreachable sometimes. Might be there, it is not reachable from the user's location. There can be multiple reasons that a public IP or elastic IP that you have associated to a domain, it is not reachable. So you can have this one set of public IP or the elastic IP. You can have another set. You can have another set of PIP or the EIP, which means public IP of the elastic IP. The reason being that, for example, let's suppose if the first set, if my first public IP or the elastic IP goes down, then my domain name can resolve accurately and efficiently to the second one. So you can have multiple set of public IPs or the elastic IPs assigned for your instance to increase the chances of the reachability and to reduce the chances of the downtime. So in some of your applications, you may assign multiple IP addresses to your instances to increase the chances of availability, so that if the DNS sometimes due to some backend errors, if it is not reachable for one particular instance IP, I would say that, then it can resolve to some other public IP. So both these set of IPs can be assigned to the same instance. Now, if you want to accomplish this kind of thing, you have to use the elastic network interfaces. If you want to assign multiple set of IP addresses to your instance, there's no other way. There's no other functionality that can help you to achieve this. So it's an interview question. Sometimes you may be asked that how you can assign multiple IP addresses to an instance. It can be done only through the elastic network interfaces. There's no other way out. So I go back. So let's let you know the procedure for that. I go back, I choose my network interface, this ENI, and go to Actions, and go to Manage Private IP Addresses. Right? I click on this one. This will take me to a window where I can assign multiple set of IP addresses to the same network interface. So this is the private IP and the associated public IP. Now at the back end, these private IPs are mapped to the public IPs using this concept called NAT, or Network Address Translation. I need to assign a new set of public and the private IP as per my requirement. So I click on this tab, assign a new IP, and now I can just leave it as auto assign. It will assign a private IP to it automatically. So it will just get any of the private IPs from the subnet range, right? Because this is being launched in this subnet 172.31.0.0/20. So it can pick any one of the random available private IPs, I would say that, from the pool and assign it to it, right? Or I can use another method, that's the manual one. I can just assign any random private IP to it. So I just keep it as 172.31.10.153, because I'm thinking that might be because this should be this is a free IP within the same subnet range. Okay, so this is a manual private IP that I'm assigning it, a secondary private IP that I'm assigning it to this network interface. Rakesh, your question is, if the instance is not a part of the VPC, still the private IP will be assigned to the instance? Rakesh, an instance will always, okay, the thing is that if the instance is not a part of the VPC, right, then still the private IP will be assigned to the instance. See, the thing is that if you want to assign the private IP to the instance directly in the instance should be in the same virtual private cloud. That's the condition, right? So the instance should be in the same VPC where you are doing this kind of where you're managing your network interface. And it is quite obvious that you will pick the instance in a VPC and you will perform all these operations over there. So the instance should be in the same virtual private cloud. So now I type in a manual random private IP to it, and it says you have specified a private IP address that will be assigned to the network interface. It says, do you want to update? Yes, update. So now I've assigned a secondary private IP to my network interface. So if I check the details, you can say it is showing the secondary private IP as 172.31.10.153. And if I just go back to the instance, the same would show up in my instance details. You can see under my instance details on the description, the main private IP is .152, and the secondary one that we have assigned manually .153. So what I want to show over here is that you can assign multiple private IP addresses or the public IP addresses to the network interfaces, and the same will be replicated for your instances. So in a nutshell, you can use this method to assign multiple IP addresses to your instance. Let's go back. Now, I've assigned an additional or a secondary private IP. Let's suppose I want to assign a public IP. Now, my question to you guys is, I just want to know that how attentive you are. I want to assign a public IP to this private IP. Now, the public IP is how I can go ahead and manually assign a public IP to this private IP. How I can go about doing that. So I'm just looking forward for the inputs from your side. I guess I've discussed this concept before the break. So I want to manually assign the public IP to this private IP 10.153. How I can go about doing that? So Shrikanta is saying it is not possible as a public IP is assigned from pool. Of course, Shrikanta, or I would say I can, yeah. So Srinivas is saying elastic IP. Yeah, good point. See, the thing is, public IP is not in our hands. It is never controlled by us because the public IP is completely controlled from the Amazon Web Services or the AWS perspective. Public IP cannot be manually associated or disassociated because it's a completely automatic procedure which is not in our control. So Sandeep is saying elastic IP. Yeah, that's correct. So the only alternative is that I have to go with the elastic IP that will work as a public IP for me in this example, right? So I need to associate an elastic IP to this private IP 172.31.10.153. So I go to elastic IP dashboard, allocate a new one. Yes, allocate. And I go to actions and associate it not to the instance this time. In our previous example, we had chosen the instance. This time, we'll choose the network interface. Okay, so I think this is the one. I choose the private IP 10.153 and hit associate. Now I just go back to my network interface details, go to actions, click on manage private IP addresses, and now you can see this elastic IP, which is equal to the public IP as of now, is being assigned to my private IP. And now if I just go back to my instance, you will see it has two private IPs, and now it has two public IPs as well. Let me just highlight it. This one. So using the concept of elastic network interfaces, I mean to make this thing very much clear that you can assign multiple set of private and public IPs to a single EC2 instance. Right. So that's the first capability. Now, let's discuss our second capability. Now, apart from assigning the multiple IP addresses, you can also use the elastic network interface. Now, in the short form, I'll just term it as ENI. You can use the concept of ENI to perform the detaching and attaching method, and you can read out the traffic. See, if you pick any one of these of the network interface, these three things are being associated to any of the network interface: private IP, public IP, and the MAC address. For example, these three properties are being assigned to this instance A, right? And this is the elastic network interface, ENI, and these are the three properties that it carries. In the same availability zone, let's suppose if my instance B is a standby server, Now, what happens is, for example, due to some reasons, this instance A goes down. You can take this ENI and attach it to instance B. What will happen? All these things, private IP, public IP, and the MAC address would be now associated to instance B, which will help to reroute your traffic. So the concept of elastic network interface help you to perform the failover procedure within the same AZ. Now I'm saying this is not a quite efficient because you have so many procedures in place like auto-scaling load balancer. But till that we just get to that point, we can see that these are kind of workarounds, right? So let me do one thing. Now this kind of detaching and attaching method cannot be performed on the default network interfaces. That's a restriction we have to take care about. If I go to this default, now how you can recognize a default network interface? You can recognize it using this ETS0. If I just click on over here and I go to actions, you can see the option to detach is being created out. Under the actions where you have attach and detach is being created out. Now I can assign multiple network interfaces to the same instance. Now I'll get to that point. What's the purpose I'll achieve by doing that? But I can do that. So on the top where you can see my cursor, I can just click on create network interface. Once I go to create network interface, I'm showing about over here where my cursor is. This one, right? Create network interface. So I click on create network interface, and now I can just type in secondary. This is my secondary network interface that I would be assigning to my Linux instance. Now I'll come to that point that what are the other advantages by using the secondary ENI. Apart from doing the failover procedure, it can also help you to create a management network. Now once you click on choose secondary ENI, now you have to keep one thing in mind. If you want to attach the ENI, now please make a note of it, it's a very important point. If you want to attach an ENI to an instance, both these two components should reside in the same AZ or the availability zone. Otherwise, the failover procedure will not be successful. So if I just go back, if I want to attach this secondary ENI to this instance, I need to check what its availability zone is. It is US West 1B. So if I want to create a secondary ENI and attach to it, I need to ensure that the secondary ENI I'm creating should reside in the same availability zone of the US West 1B. So I go back to the network interface dashboard. I click on create network interface, and I just name it as the same thing, secondary ENI, as I did before, but I just cancel out because I need to show the instance dashboard. So this is secondary ENI. Now I choose the US West 1B as my preferred AZ. I keep the private IP as auto assigned so that it can pull out any of the private IP addresses from the pool. And also I need to assign a security group to the network interface, because you can give a detailed level of understanding or a detailed level of, I would say that you can define what kind of traffic can reach a particular instance. So might be your instance has two network interfaces. Each network interface can receive a different kind of traffic. We'll discuss that. So I'll just choose the security group and hit create. Now right now this network interface is being created, but it is not attached. So if I just go back, you can see on the top, what is that? Yeah. So this one, the top one is being created, but it is not attached. So I just go ahead, click on attach, and choose the instance in the same AZ, and hit attach now. So now this instance in my US West 1B has two network interfaces. So if I just highlight, this ETH0 is my default one, this one. This is my default, and this is the secondary one that I just created and managed to attach it with my instance. To my instance, I would say that. So as I start adding more network interfaces, it will be ETH2, ETH3, ETH4, and it will increase in numbers. Right. Now, if I just go back to the ETH1, it will have its own unique properties. It will have its MAC address, which is unique in nature. It will have its private DNS. It will have its private IP. Let's do one thing. Let's go ahead and assign an elastic IP to it. So if I just go to Actions, click on Manage Private IP Address, I need to assign a public IP or an elastic IP for this private IP right now. So what I would do, I just copy and paste this elastic network interface. I go back to elastic IPs, I allocate a new one, and I go to Actions, associate it to my network interface, and hit Associate. So now, this elastic network interface, if I just go to Actions and go to Manage Private IP Address, it has this elastic IP now, right? So if I check the details, these are the three details I'm mainly stressing upon: MAC address, there's private IP, and the public IP. Now, this secondary network interface is being assigned to my Linux instance in US West 1B, right? Now let me do one thing. Let me just assign another instance real quick in the same AZ. So I go back to my instance dashboard and just launch another instance in the same AZ of US West 1B. Let's name it as test ENI. Right. Hang on one second. So I've just launched the instance in the same AZ or the availability zone. Now, if I just go back and just check the details, this test ENI, this ENI instance, I would say the test instance, that would be more appropriate term to assign to it. This that I've just launched right now, this has its own default ETH0. What I would be doing is I would be detaching. So this is my Linux instance I've just chosen right now. I will be detaching this ETH1 and attaching it to the test instance in the same AZ. So I go to ETH1 that is assigned to my Linux instance and click on detach. Sometimes the detaching method is not that much simple because you may need to stop the instance first. But let's hope that it lets me detach even if the instance is running. Okay, you can see this is me detached now. I go to attach again, and this time I choose my test instance in the same AZ. And now, if I just go to the instance, it will have two private IPs and two public IPs, which means that the previous properties of my ETH1 has been carried over and been associated to the test instance. So this thing helps me to read all the traffic, because while I'm performing this detaching and attaching method and this hovering over the ENI from one instance to another, I'm carrying over all these three properties. Now the network traffic, it communicates using the IP addresses and the MAC addresses. Therefore, what happens is that this will help us to read all the traffic to any instance in the same AZ in case of a failover. So this ends our second overview of the advantage of the elastic network interface. Sure, the question is how many IP addresses we can assign to an instance. Sure, there's no limitation as such, but yes, you have the limitation for the network interfaces. It depends upon the instance type, which instance type you're using. For example, with the T2.micro, I can't have more than 2 elastic network interface, but there's no restriction for the IP addresses as such. Okay. So this is our second advantage of the elastic network interface. The first one is that it helps you assign multiple IP addresses to the same instance, and the second one is that it helps you to perform the failover within the same AZ. Right. Now let's discuss our third advantage. The elastic network interface helps you to create a management network. Now let's see the details of this. Now don't go and into the details of this diagram, because I just try to keep it simple. I just took this diagram from the AWS documentation. But if you just make a closer look or take a closer look on this diagram, this is a web server, or I would say, in other words, this is an EC2 instance that is being residing in the middle. You have the two different subnets in the same AZ, AZ1A. In the AZ1A, you have this ETH1, that is secondary network interface that is residing. On the right side, you have ETH0 on the right side. In this another subnet, but it is in the same AZ. This ETH0 is handling your something called management traffic. This one. So the default network interface of your web server or an EC2 instance is handling the management traffic. Opposite to it, the ETH1, that is the secondary network interface, is handling something called public traffic. Public traffic means that it is the traffic that it is receiving from from the internet, whereas the management traffic is the one that is being flowing to and fro between your data center and the AWS cloud. Right? Now my question to you guys is that I have a web server with two network interfaces, and each network interface is handling a different kind of traffic. Now I can very easily have one web server over here handling my public traffic, one web server over here handling my private traffic. Why on the earth I want to make this design more complicated and have a single web server handle two types of traffic? I would say how it will help me to create a management network, or at the end what I'm trying to save over here, because I can very easily have two instances running in different subnets having different kinds of traffic. Why on the earth I'm making the design complicated and have the same web server handle two types of traffic at the same time? What I'm trying to accomplish, what I'm trying to gain over here. So I'm just waiting for the inputs from your side. Any questions? Any inputs? Anything that you want to add? what I'm trying to achieve over here, if I assign one web server, one instance to handle two types of traffic, I can get the same work from two instances, one instance in each subnet, and get the same kind of performance. How it can help me to create, I would say, a cost-effective method. So I've already given you a hint. Shrikant is saying keep the confidential data separate. Shrikant, even if we have the two instances in each subnet, it can also keep the confidential data separate. The thing that we're achieving over here is that it will help us to save cost. Simple. See, in our companies, if you are an employee and you have multiple skills, you're more valued. Because if a company has to hire multiple people for multiple skills, they have to add more money, give more benefits to more employees. It's the same thing. Instead of having multiple servers to accomplish different kind of traffic or to accomplish different type of functionalities, you have a single web server that can handle multiple types of traffic at the same time. So this helps you to lower down your cost. See, right now we are just focusing on only one web server, just as an example. Let's suppose that in your environment you have 1,000 instances. Using this kind of effective method, you can lower down from 1,000 instances to close to 500. So what are you saving? Dollars. You're saving your cost in designing or managing your entire architecture. Yes, this requires the proper planning and the capacity provisioning, but the reason being because this will eventually increase the load on the web server. So you have to perform the calculations that, okay, if you choose a higher end of web server and you let that web server handle different kinds of traffic, how it will help you to save your cost in the longer terms. This kind of design involves proper planning. But yes, if you are able to accomplish this kind of design, in the longer run, it will help you to save your cost. It will lower down your cost to I would say 50% or 60%, depending upon how efficiently you use this kind of method. So this is the third major advantage of the ENI, that it helps you to create a management network where a single web server can handle different kinds of traffic at the same time. I guess you agree with my point. Any questions or any doubts, you can let me know. Srinivas is saying failover. Srinivas, we can also do the failover by having two different instances, right? So this is about creating a management network, right? So in a nutshell, we have discussed about the elastic network interface. An elastic network interface helps you to assign multiple IP addresses to the same instance. It helps you to perform the failover within the same AZ, and also it helps you to create a management network where you can reduce the number of instances that was initially required before. So this is all about the network interface. Now let's discuss some important points. Best practices for configuring network interfaces. First thing first, ETH0 cannot be detached from an instance. The default network interfaces cannot be detached, or I would say it cannot be disassociated and attached to any other instance. This can only be performed with the secondary network interfaces. An ENI has to be the same AZ where the instance resides, so that it can be attached to the instance. So both the network interface and the availability zone should reside in the same availability zone. If this is not the case, the association will not be successful. There are three types of attaching methods. Hot attach. Hot attach means that you are attaching a secondary network interface to an instance when it is running. In all these examples that we've discussed so far, we have performed the hot attach method, where we have attached the network interface to the instance when it was in running state. Warm attach means that you're attaching the network interface to an instance when it is in stopped state. Cold attach means that this is more relevant to the default network interface. So the default network interface gets associated to your instance during the launching procedure. So that's called the cold attach. So these are the three type of attaching methods for your network interfaces. So this completes our network interface, our third topic for this day. Any questions, any doubts? Feel free to let me know before I can just jump over to the load balancer. So I'm waiting for your questions. I'm just pausing for a few moments. You can just shoot your questions. Once we're done with the questions, I'll start discussing the load balancer. I guess we have a question right now. Rakesh is saying, I noticed that when we have two private IPs, for instances, we have different elastic IP and public IP. So they are same as I believe. Rakesh, as I stressed before, elastic IP and the public IPs are same, right? So elastic IPs and public IPs are same because both make your instances publicly accessible. But the nature, the way they work is completely different. The purpose of both the elastic IP and the public IP is to make your instance publicly or accessible from the internet. But the way they work, their nature, their behavior is completely different. Okay? So if you have two private IPs, one IP is associated with the public IP, the second one is with the elastic IP, you can say that elastic IP is also a public IP itself. Okay? Right, yes, Rakesh. Even though see, the thing is, even though they're not same, because each private IP will have its own associated elastic IP or the public IP. They are not same, but you can use both IPs to reach your instance. Okay? Okay, I guess we are done with the time. Done with the, I'm sorry, this network interface. We'll now discuss another topic that's called the load balancer. That's quite important. Till this point of time, the processes that we have discussed so far, these are the manual failure processes. Right? These are manual failure processes, means that you have to perform these things manually. But now we'll start discussing the automatic procedures in place. Because if I want to say the administrator that, okay, no, you have to perform the failover using elastic IPs or network interfaces, it doesn't sound too much exciting. It's a boring procedure, because at the end you have to recruit more people to perform this kind of troubleshooting thing. So nowadays it's an era of automation where you want that everything should be automatic. Whether the cards, whether the infrastructure, everything should be automatic. So therefore, as our first automatic procedure, we'll discuss the concept of elastic load balancer. Now, for the guys who have not been paying attention so far, please pay attention because now the real thing is been beginning. So I need to pay. I request you that this topic that I will be discussing, the load balancing and auto scaling, it's quite important. At least 30% of the questions come up from the load balancing and the auto scaling, because these two topics are related to each other. They're associated. So if you don't understand the load balancer and the auto scaling, means that the 30% of the questions would not be answered correctly in the examination. And also, these are quite important to create a highly available and fault-tolerant design, right? So as an architect, if you want to become an architect in the Amazon Web Services, it is quite important for you to understand these services efficiently. You have to go in deep and understand these services. So I'll try my level best to go in depth, cover each and every aspect, each and every concept of these topics. If you feel that you have any questions, you need more assistance, please feel free to ask me as many questions as you want. All right? So let's start. I think my PPT, the PowerPoint has been frozen. Hang on one second, please. Sometimes it happens if I open more PPTs on the PC, it tends to freeze because it's a Microsoft product. I'm running on the MacBook, so there's already a kind of, you can say, using the Microsoft product on the Apple product. Hang on one second. I think I need to terminate this. I need to exit out. Screen is completely frozen as of now. Just give me one moment over here. I think I need to do something to make it work. Let me just open another desktop. I think. Okay. I need to force quit. Now I'll just open the slides again. Alright, so elastic load balancer or the ELB. So we'll discuss the basic concepts of it, and I'll just jump over to the practical side. So what's a load balancer? A load balancer automatically redistributes the incoming traffic to your set of EC2 instances. Sorry. See, what happens is that in an ideal situation, you will never have an external user send the traffic directly to your instance. You will have the user send the traffic directly to the load balancer, and from there, the load balancer will redistribute the traffic to the instances that are reporting to it. These instances can be a part of a single AZ, or these instances can be a part of different AZs, depending upon how you have structured and designed your network. It literally load balances the incoming traffic between your instances. So if I'm saying load balancing the traffic, it means that it ensures that each instance gets its equal share of traffic. These EC2 instances can be either collected together in a single AZ, or they can be spanned across multiple availability zones. Now, apart from automatically redistributing and load balancing the traffic to all the instances running in different AZs, another purpose of the load balancer is to perform the health check. See, the thing is that there should be something in the place to proper monitor your instance and see whether the instances are in good shape or not. Because if you have deployed some automatic procedures in place, you have to trust upon that. Because if the automatic procedures or the automatic tools that you have deployed, if they're not capable to get to know whether the machines running in your, or the servers running in your architecture are responding or not, then somewhere down the line you will not rely upon those automatic tools, or you will obsolete them. You will take them away. So an automatic tool or an automatic procedure has to be efficient enough to detect some loopholes, some unhealthy instances in your architecture. As a consequence, the responsibility of the load balancer is to detect whether the instance is unhealthy. Now, if I'm saying an instance is unhealthy, there are many things related to it. An instance can be unhealthy because it is stopped, might be it is in frozen state, might be it is terminated. There can be multiple reasons that I can say that instance is unhealthy. Might be it is rebooting itself. Now, as soon as the load balancer gets to know that this instance is unhealthy, it will stop sending the traffic to it and say, hello, you're not responding. I'm cutting the flow of the traffic to you. Now you might be wondering, okay, we can sense that, okay, load balancer will get to know this instance is unhealthy and it will stop sending the traffic to it, but how it will benefit to us? The benefit that we'll get from this kind of thing is that the user will never reach this instance. For example, let's take an example first. This is a user. He is sending the traffic to your ELB. That's a short form of Elastic Load Balancer. This ELB is sending the traffic to this instance. This is instance 1. This is instance 2. Let's suppose there's something wrong with this instance 1. It goes down. If the load balancer routes the user traffic, if it routes the user traffic to this unhealthy instance, the user will not be able to access the website, and he will get the page can be displayed. Right? So as soon as the load balancer will get to know that there's something wrong with instance 1, it will stop sending the traffic to it and reroute the traffic to another instance. That is healthy. So to avoid the situation where the user may land to an unhealthy instance, the load balancer, once it gets to know that that instance is unhealthy, it is not responding, it will cut the user's traffic flow towards it and reroute the traffic to another healthy instance. I think it makes sense, right? Now, the responsibility of the load balancer does not end over here. If I'm saying the responsibility, which means that even if this instance is unhealthy, the load balancer will keep an eye and a track on it. It will say, okay, instance, I get to know you're unhealthy. Now you're healthy now? Are you up? You're back up? So it will keep on sending the keep alive messages or the ping messages to it to just get to know that that instance is up and running now. Once this instance gets back up, then the load balancer will start sending the traffic to it or resume sending the traffic to it. It will say, hey, instance, you're healthy now. I'm sending the traffic to you. Right? So apart from automatically redistributing and load balancing the traffic, the responsibility of the load balancer is that it should always ensure that your architecture is in good shape. The instances are running as intended. They are in a situation to respond to user queries. If they are not, the load balancer will stop sending the traffic to those unhealthy instances, reroute the traffic to the healthy one. If the unhealthy instances come back up, the load balancer will now start sending the traffic to them. So these are the major functionalities or the responsibilities of the load balancer. you can assume your load balancer as a traffic manager. Now, what does a traffic cop or a traffic police in the city does? A traffic police or a traffic cop ensures that none of the roads nearby are being jammed. It's the same thing with the load balancer. It acts as a traffic manager. It ensures that everything is fine and none of the traffic is flowing smoothly within your architecture. It distributes and manages the entire web traffic efficiently. It ensures that none of a single instance is overloaded. So each instance will get an equal share of the traffic. So the traffic is distributed evenly across all the instances. So each and every instance will get its equal share of traffic. Plain and simple. Right? So we already discussed this point. Your load balancer, it facilitates continuous health monitoring, which means it will send the keep alive messages to your instances after a few seconds and get to know whether they are responding or not, whether they're healthy or not. Now, we have seen the functionality of the load balancer. Any questions so far? Any questions so far? So, three main functionalities we have discussed. It automatically redistributes the traffic, load balances the traffic, and performs the health check. Any questions and doubts so far before we can just proceed and discuss more in-depth concepts? I think it's clear so far now. If you have any questions, do let me know. I think no questions as of now. Now let's see a higher overview of the load balancer. A load balancer helps you to create or build a fault-tolerant design. How? Let's see this diagram as an example. Okay. Over here, you have this load balancer, and this load balancer is redistributing the traffic to all the instances. So you have to keep one thing in mind. A load balancer is specific to a region, which means that it can load balance the traffic upon different AZs within the region. A load balancer will never surpass a region. So we have this load balancer in Northern California, and these are the three different AZs reporting to it. Now, this load balancer is sending the traffic to all the instances in different AZs. Now this AZ, US West 1A, it goes down for some reasons. Might be due to some natural calamities, might be the Amazon Web Services, they have shut down this AZ due to some maintenance purpose. Now as soon as this US West 1A goes down, the load balancer, it will send the health check messages to the instances and will get to know that all the instances in the same AZ are not responding. So load balancer will smell something wrong, that okay, there's something wrong, and it will cut down the traffic flow to the entire AZ and reroute the traffic and divert the traffic to other healthy AZs or the instances. So each AZ will get the 50% of the traffic now. Previously there were 33%, 33%, 33%, but now each instance will get a 50% of traffic. Which means that your elastic load balancer provides a great level of fault tolerance and reroutes the traffic in case of an instance or an entire AZ fails. So load balancer is a quite effective tool or a service. I would say tool is not the right term, but a service to help you or ensure that your design or the application that you're running, it is up and running all the times. It makes your design more highly available and more efficient and more fault tolerant. Right? So let's move further now. Now, the Elastic Load Balancer supports 4 different types of traffic. HTTP, HTTPS, that's a secure version of HTTP, TCP, SSL, that is a secure version of TCP. Regarding the pricing, it is same as pay-as-you-go model. You pay only for what resources are being used by you. So you pay for the time duration. Now for the in the free tier account, you get one load balancer that you can run free for the entire 1 year. But in the business account, that's a different case. So you pay by the hourly charges for the load balancer, and you also pay for each gigabyte of data that surpasses the load balancer. You might be wondering what's each gigabyte of data that's surpassing. So what happens is that if this is a user and he's sending the traffic to the load balancer, this load balancer is distributing the traffic to other instances. So the user will send the traffic through the load balancer and it will reach your instance. So this amount of traffic that surpasses the load balancer and reach your instance is being calculated on each gigabyte basis. So you have to pay for each gigabyte of data or traffic that surpasses the load balancer and reaches your instance. So this is how the pricing is being determined for your Elastic Load Balancer. So this completes our theoretical overview of the Elastic Load Balancer. Any questions, any notes before we can just jump over to the practical side? I guess we have 2 more points left. Now the load balancer are 2 types. Internet-facing load balancer. Internet-facing means that it is intended to receive the traffic from the internet. And we have the internal load balancer. So the internet-facing load balancers are exposed to the internet. The internet-facing load balancers should always receive the traffic from the internet, whereas the internal load balancers are not exposed to the internet and are purely intended to carry out the internal operations inside a virtual private cloud. So these are the 2 types of load balancers that you will incorporate in your design. Internet-facing load balancers are exposed to the internet. They receive the traffic from the internet, whereas the internal load balancer, it receives only the internal traffic. It carries out or manages the internal traffic. So these are the 2 types of load balancers. So this completes our theory of our ELB. Any questions, any doubts before I can just jump over to the configuration aspect? I guess no questions as of now. Okay. Let's move forward now. So no questions. Guys, please don't be hesitant or reluctant to ask questions. Okay. Just in case, even if you have the slightest doubt, please feel free to ask me. All right. All right. Now let's go ahead and launch our load balancer. So a load balancer can be idly situated. It can be tracked under the EC2 dashboard, where you have all these stuff, elastic IPs, key pairs, blah blah blah. So underneath you have this load balancers. So let's go ahead and launch our first load balancer. So you have to keep one thing in mind. A load balancer is specific to a region. So I've chosen North California. This load balancer will work only for the North California region only. That's it. I go to create load balancer, and at the first step 1, I have to define the load balancer that I'm going to just create right now. First thing first, I have to choose or define a load balancer name. So I'll just name it as test ELB. Create the load balancer site. VPC. See, the thing is, this load balancer is also a part of a virtual private cloud. If I just create a diagram to make it more understandable, just to create a pictorial representation, what I'm trying to say over here is, let's suppose if this is your VPC or the virtual private cloud. Yeah, forgive me because I have a very bad drawing. Now, this is your entire VPC. This is entire virtual private cloud. This is your ELB or LB, load balancer. You have this instance. So this is in subnet A, that is associated with my AZA. And this is another instance in subnet B that is associated with my AZB. Right. Now the load balancer is sending the traffic to, or load balancer traffic to both instances in different subnets or different AZs. So a user will send the traffic from the load to the load balancer, and from there subsequently the load balancer will read out the traffic. So you have to ensure, over here you have to ensure that this load balancer and these instances should be in the same virtual private cloud. Now we'll discuss the concept of virtual private cloud in detail. A virtual private cloud, it's your own private data center or a virtual private data center in the cloud. So I guess it makes sense. If you want to load balance the traffic upon the instances and the load balancers should be in the same virtual private cloud, in the same VPC. You can't have a load balancer in a different cloud and the instances in a different cloud. All the components, whether it's a load balancer or the instances, should be in the same VPC or the virtual private cloud, in the same region. Right? I guess it makes sense. So I just go ahead and choose my, so it says create a load balancer assigned. So I would choose my default VPC in the Northern California region. The third aspect or the third configuration piece that I have to choose over here is called create an internal load balancer. So we have discussed type of load balancers, internet facing and internal. By default, each and every load balancer that I create, any load balancer that I create, it is being assumed or taken as the internet facing. If I check mark this option, it will become the internal load balancer. If I keep it unchecked, it would be the default one, that's the internet facing load balancer, which means that it will receive the traffic from the internet. Next, we have to choose something called enable advanced VPC configuration. What is that? If I check mark this option, I can select different subnets associated with different AZs in the same virtual private cloud. So I'll choose both the ones. So I click on plus sign and choose all the AZs and the associated subnets, so that the instances in these subnets in different AZs can receive the traffic successfully from the load balancer. So you have to be very careful while selecting the subnet, because if you miss out any of the subnets, so that subnet or the instances in that subnet will never receive the traffic from the load balancer. So as of now, I've chosen all the subnets to receive the traffic from the elastic load balancer. Next, we have something called listener configuration. This one. Now, let me discuss what's a listener configuration. Listener configuration is a process of listening to your request. See, the load balancer differentiates the traffic in two different categories. So let's suppose that if this is a user sends the traffic to the load balancer, and from here the load balancer balances the traffic to different instances in different AZs, or they can be the part of the same AZs. That's a different story. Now the traffic that flows between the user towards the load balancer is called a front-end traffic. Right? And the traffic that flows between the load balancer and the instance is called a backend. So the traffic that flows from the user to the load balancer is called the front end, whereas the traffic that gets forwarded from the load balancer towards the instance is called the back end traffic. Right? Depending upon this concept, and based upon this concept, we define our load balancer configuration, or called the listener configuration, to be specific. Now, this thing, load balancer protocol and port, this one, this defines your front end traffic that flows from the user towards the load balancer, and this instance protocol and port defines a back end traffic that flows from the load balancer towards the instance. This is called a back end traffic. So by defining the load balancer protocol and port, I can define what kind of traffic can flow at the front end level, and by choosing the instance protocol and port, I can define what kind of traffic can flow at the back end level. Therefore, I can choose any kind of traffic at the front end by choosing the load balancer protocol and port: HTTP, HTTPS traffic, TCP, SSL. So for example, I can choose HTTP or port 80 both at the front end and the back end level. I can add more rules where I can convert the HTTPS. I can convert the HTTP traffic at the front end, or I can take the HTTP traffic at the front end and convert that to the HTTPS at the back end. You might have seen your corporate applications. Whenever you open your corporate applications from your home, you open that HTTP and it gets converted to the HTTPS. Or you can add more rules where you can allow HTTPS at both at the front end and the back end. But you have to keep one thing in mind: if you choose HTTPS at any level, whether it's a front end or the back end, you have to upload an SSL certificate. Now, previously you have to buy the SSL certificate on your own. Now, the Amazon Web Services, they have introduced the certificate manager to get the SSL certificate from them. We'll discuss that later on, but we have to define both a load balancer protocol and port that defines our front end traffic, and the instance protocol and port that defines our back end traffic. Right? So this completes our first page, or the first step, where we have to define our load balancer. Right? Any questions, any doubts till this point of time? I guess this first page is clear. If you have any questions, please feel free to ask me right now. No questions, no doubts? Okay. All right. So we'll just click on next, assign security groups. Now, as we assign the security groups to our instances, we also have to assign a security group to our load balancer, because the load balancer, they receive the front-end traffic from the user, right? So we should be cautious that what kind of traffic should reach our elastic load balancer, right? So I click on create a security group. I'll just name it as ELB security group, right? So I can define that, okay, it can receive the HTTP and the HTTPS traffic from all the sources, or I'll just only allow the HTTP traffic, that's it, right? And I click on next, configure security settings. I can skip this step because it's not required as of now, right? And I click on configure health check. Now this is a detailed level of health check that I have to configure. So I guess we can take it tomorrow, because it will take me time to discuss all these concepts, what these timer values are. So I guess we can stop this. We had been for the day as of now. We can now discuss from the step 4 from tomorrow, because all these things will take some time for me to explain. Okay. So tomorrow we'll cover our ELB. I'll give you a short exercise or assignment to do, right? So I'll give you an assignment to perform, and then we'll start discussing our auto scaling. So today we have discussed the launching of the EC2 instance, difference between the PIP and the elastic IP, the concept of elastic network interface. We have discussed the theoretical overview of the load balancer, and we have halfway through the configuration procedure. So that's it for today. So I'll discuss from step 4 from tomorrow, because this will take some time. Any questions, any doubts before we can wind up? Tomorrow I'll also give you a short exercise. We'll just take out 15 minutes of our time, where I just give you a short exercise to do it by yourself, and you have to perform the operations on your own. So once we do the load balancer, then we'll start working on that. Any questions, any doubts? Any questions regarding the launching of the EC2 instance, the difference between the public IP and the elastic IP, the concept of ENI, the concept of load balancer? Any questions, please feel free to let me know right now. Yeah, Sharat, you have to log in as EC2-user. That's a root user. So you have all the access. So I guess you're able to log in now. Right? Previously, you due to some disconnection issues, you're not able to see the entire thing, but I guess you are able to. Yes, Sharat, you can change the password for the sudo from here. All right. So that's it, guys. I really appreciate that if you revise the concept, because the concept that we have discussed today, they're quite important. Because the difference between the public IP and the elastic IP, the concept of ENI, and the load balancer is the most important one. So tomorrow we'll continue with our conversation regarding the ELB or the elastic load balancer. Please revise the concepts that we have discussed so far. So I guess the recording gets uploaded within 3 or 4 hours of the time frame once our class gets over. So please revise the concepts. And tomorrow we will just continue with our conversation. Last but not the least, once this session gets over, please fill in the feedback form, because in our previous week only 2 people managed to fill in the feedback form. So please fill in the feedback form, because it's quite important for us to know that where we stand, where we need to improve. So once this session gets over, please take out some time and fill out the feedback form. So we'll meet tomorrow at the same time, and we will continue with our conversation. All right. So goodbye. Bye-bye.